Good afternoon, class. Today we're going to be solving rational and radical equations. And I want to, we know that a rational number is a number that can be written as a fraction. So, with that in mind, a rational equation is an equation that contains fractions. Rational means fractions. Rational equation is an equation with fractions. Now, these fractions are going to be different from the problem, one of those last problems we did on during last class period. If I remember correctly,
we had one with a fraction.
Yeah, we had one with a fraction, but notice the denominators were just constants. Numbers, and we multiplied through and cross-canceled to get rid of the denominators. We'll do the same thing here, but these denominators are going to have variables. So there's another wrinkle. We're going to start off with equations that have fractions. We're going to wind up solving an equation that doesn't have a fraction. That's our goal, is to remove the fractions. And that the problem is that fractions are not always defined. Fractions are undefined undefined means meaningless when the denominator is equal to 0. Look at this. A number divided by 0. A non-zero divided by 0, heck, even 0 divided by 0 is, what does that say? N over O. NO, that says no, you can't do it. That's undefined.
Sometimes people don't see it, believe it till they see it on a computer. On a calculator. The number 5 divided by 0 is error, divide by 0. That's how my calculator says undefined. It's saying there's some sort of error there.
If you think about it, if you think of the division algorithm, what did y'all learn in elementary school first? Division or multiplication?
Multiplication.
You learn multiplication first because division is defined in terms of multiplication. 10 divided by 2 is equal to 5 because 5 times 2 is equal to 10. The quotient times the divisor gives you that dividend. That's the why. Why is 10 divided by 2 equal to 5? Because 5 times 2 is equal to 10. Suppose we have 7 divided by 0, or any number divided by 0. What number times 0 will give you 7? No matter what you multiply, put there, when you multiply it by 0, what are you going to get? Are you going to get a 7? No, that is nothing. That's why division by 0 is undefined. On an unrelated, well, I guess it's sort of related. Here's another little thing you might want to remember. 0 divided by a non-zero constant k. That's okay. It's okay to have a 0 on top. That's equal to 0. 0 times k gives you 0. If you had 0 divided by 7, what number times 7 will give you 0? You have $0 and you're splitting it up among 7 people. How much is everyone getting? Nothing. So it's okay to have the 0 on top. It's the 0 on the bottom that's a problem. Looking at problem number 1 from the assignment, they're giving us an equation and they're asking us, basically, when are the fractions undefined? What numbers cannot possibly be solutions? What values of the variable cannot possibly be solutions for the given equation? They tell you, don't solve the equation, just decide which numbers cannot possibly be solutions.
Let me write it out. Interject. I would prefer for them to somewhere say, when are these fractions undefined? But they don't. I remember Bittinger Elementary
There you go.
Intermediate Algebra book worded it that way. But that's not the book we're using.
I was going to say, but Bittinger did write this book, right?
Beecher, you're getting your
Beecher.
B's
Oh.
confused.
Well, oops, sorry. Ah, okay. We cannot allow these denominators to be 0. So whatever you plug in here for this x, it can't make 3x plus 2 equal to 0. So what I'm going to do is I'm going to say 3x plus 2 can't be 0, and x minus 5 can't be 0.
Now, that's the easier one to figure out.
Mm-hmm. We can figure this one out right here. That's not bad at all. Treat that not equal to as if it were just an equal sign. You want to get x by itself, what are you going to do?
Move it to the
Move the 5 to the other side. That minus 5 is going to become a positive 5 or a plus 5. So x can't equal 5. You can't plug in a 5. If you try to plug in a 5 here, you're going to get 1 over what number? 0. That's why we say x can't equal 5. So if we were to solve this equation and get x equals 5, we'd have to mark it out.
Every one of these problems is going to have the option of no solution.
Okay, this one here, 3x plus 2 can't equal 0. That means 3x cannot equal negative 2. Then what am I going to do to get that x by itself? Divide by 3. So here's the other number that cannot possibly be a solution. If we were to solve this equation and we got negative 2/3 as an answer, we'd have to cross it out.
So it's possible to have no solution today.
So the numbers that cannot possibly be solutions are negative 2/3 and positive 5. We're not solving these. Don't start thinking, oh, this isn't bad, okay? We're not to that point yet, okay? We're not solving them. We're just figuring out what numbers could not possibly be a solution. If we went through and solved it and we got x equals 5 as a solution, we'd have to mark it out. So
maybe we have it too big.
I think so.
Minus?
Mm-hmm. Okay, let's see. You know something, instead, just do this.
But
There.
that still doesn't make it any better.
And scroll down.
Okay.
Uh-oh, that's bad, isn't it? Type in the answer, negative 2/3. The solutions cannot include the fraction negative 2/3. You need a comma. Do not put the comma in the denominator. Even though some nice programmers have done you a favor and they allow it under for certain problems, once we get to the interval notation problems that are coming up very soon in 1 week's time, you start putting commas in denominator, so everything is wrong. Just make a habit. Never type a comma in a denominator. Any questions there?
So these are not solutions. Those are the numbers that, if you were going to guess, can't possibly be solutions.
Now it's too small. That's better? I guess so. Okay, here's another one. Same instructions. They want us to figure out which numbers can't possibly be solutions. Here there are 3 distinct fractions. So this is number 2. Let me write the problem down. What are you doing, Tony? Okay, 1 over x minus 4 plus 1 over x plus 3 is equal to 1 over x squared minus x minus 12. The only thing that matters are the denominators. When you're trying to figure out which numbers cannot be solutions, the numerators don't matter. A numerator can be anything. I could change this problem to say 15 there instead of just 1. It wouldn't change the final answer. The only thing that matters when you're figuring out which ones are unacceptable solutions, the only thing that matters are the denominators. X minus 4 can't equal 0.
Hopefully they see there's two easy ones here.
X plus 3 can't be 0. And x squared minus x minus 12 cannot be 0. Once again, you work with those not equal to as if it's just an equal to. Solving the first one, we get x cannot equal. Be careful, not negative. Positive 4, good.
Mm-hmm.
You move it over and change the sign. So there's the first one. What about the second one? X cannot equal
-3.
negative 3. There's the second one. Uh-oh, the third one.
Not so obvious.
Not so obvious, but it's a trinomial. And at no time do they mention that we need to use the quadratic formula in the problem. So that makes me think it's factorable. It's going to factor very nicely. X squared is an x times x. 12. That's a 1 times 12, a 2 times 6, or a 3 times 4. It's a simple trinomial. So you want the pair that subtracts to give you, what's that number in front of x right there? Just a 1. 3 and 4, I think it's going to factor as x minus 4 times x plus 3. You'd be surprised how often you can come up with equations like this where two of the denominators are factors when you factor the quadratic denominator. Set each factor equal to 0. Hey, are we even going to get...
See it.
Yeah. Wait a minute. What are we about to get
How
here?
many answers are we going to have here? 2 or 4?
Aren't these going to be... Haven't we already got these numbers? Our solutions are positive 4 and negative 3.
Answers.
Our answer, not solution. Our answer, the numbers that x cannot possibly be equal to, are 4 and negative 3.
If these turned out to be the answers, you got to mark them out. Oh, those are easy to type in. No fraction. So let's see. 4 and negative 3. Check it. Okay.
Any questions there? Well, it's time to start solving these equations. So to solve a radical equation...
Rational?
Rational. Why do I keep saying radical? To solve a rational equation, we're going to do what we did with that equation back in the previous assignment. We're going to multiply through by whatever it takes to cancel out the denominators. What we used the last time was the least common denominator. That's what we're going to do here. We're going to multiply both sides. Multiply both sides by the least common denominator. Multiply both sides by the least common denominator to... I think I'm not even going to say that, okay? But I'm going to make a note right here. We're multiplying both sides by the least common denominator. We're going to have to distribute. Remember, you're going to have to distribute that least common denominator over every term. Look back at what we did over here. We didn't just multiply, we didn't just multiply that first term by 15. You had to distribute, so you wound up multiplying all three terms by 15.
Even 4.
0 times 15 just stayed a 0. But we're going to first of all multiply both sides by the least common denominator. You'll cross cancel to cancel out every denominator.
Let's see.
Number 3, at this point you'll have an equation that doesn't have fractions. It'll either be linear or quadratic. And we know how to solve both of those types of equations. So I'll say solve the equation, And step number 4, you have to make sure that the solutions you get don't give a denominator of 0. So I'll say cross out any solution that gives a denominator of 0. So we'll multiply both sides by the least common denominator. We'll cross cancel to cancel out every denominator. We'll solve the equation. Then we'll cross out any that give us denominators of 0. And we'll discuss how to find least common denominators for algebraic expressions as we move through the examples. Okay? So let's look at number 3. Notice it doesn't ask what numbers can't be solutions. They're saying to solve it. Hey, when you look at the first denominator. That first denominator is a constant. It's a 3. Will it ever be 0? No, there's no variable. What number here, the second fraction, what number would be undesirable? What number would make that denominator equal 0? It should be obvious. 4. So if you solve the equation and you get x equals 4, you're going to have to put a slash through it, okay? But let me write this problem down. We have, let's see, I'm going to spread it out. So we have a 3x plus 3.
4.
Number 3. We have a 3x plus 4 all over 3 minus, I'm spreading it out, we have a 4x over x minus 4 is equal to x. 3x plus 4 all over 3 minus a 4x over x minus 4 is equal to x. To determine the least common denominator, notice each denominator is different. I asked myself, can I factor those denominators? 3 is just a constant. No, it can't be factored. The x minus 4, can we factor that? Is this denominator like this thing here that can be factored? No, it's a linear denominator. Neither of those can be factored, so your least common denominator. If you have distinct denominators that can't be factored, to find the least common denominator, you multiply the two denominators together, or however many denominators you have.
I don't think they can have more than 2.
I know, but I'm just saying in a future situation, if they're taking another class and they have 3 denominators, then if the denominators cannot be factored and they're different, then the least common denominator is just the product of the denominators. And we're going to multiply. We have to multiply both sides, but realize terms are separated by pluses and minuses and equals. This fraction is one term. We have a second term. How many terms do we have on the right? 1. So there are 3 terms. You're going to have to multiply by this LCD 3 times. I'm going to put a 3 times an x minus 4 right there over 1. I'll enclose those in parentheses. I think it makes it look better. I'll multiply this one by 3 times x minus 4 over 1. And I'm going to multiply this by 3 times x minus 4.
Some people might want to put that 3 in front of the x.
And that's fine. Now you start canceling.
And hopefully you won't have any fractions remaining.
3 divided by 3. So we can cancel the 3. We have x minus 4 times 3x plus 4. Minus, this black minus is this minus right here. Look at the second product. Y'all tell me what's going to cancel out here. And the second product, what's going to cancel out? Remember, you want to cancel out everything except 1 from the denominator. So what will cancel in the second product? Frankly, it should be obvious. X minus 4. That's why we used an x minus 4, because we had a denominator of x minus 4 that we had to cancel. So we have a 3 times a 4x. 3 times a 4x left.
As you do more in these, you just write 12x there.
And then this last one. I don't see any fractions here. Is anything going to cancel? Cross cancel? If you don't have fractions, you can't cross cancel. X times 3. You have a 3x times x minus 4. Any questions on my logic? X times 3, we traditionally write that as 3x. And we're going to multiply that by x minus 4. Any questions? This was the big step. Going through canceling those fractions. The rest of it is just messy foiling and combining like terms. But the new stuff is the way I was able to multiply both sides by the least common denominator to cancel out everything except 1's from the denominator. Any questions there? Well, now we have to go through and remove all the parentheses. It looks like it's probably gonna be quadratic by the looks of it. Let's see. What are we gonna do to remove these parentheses? 4-letter word starting with an F. Okay. X times 3x, that's a 3x square. Outer. X times a positive 4. Okay. Inner. You have a negative 4 times a positive 3x. Negative 12x, I agree. Negative 4 times positive 4 gives me a. Okay. Now the minus, we have that minus there. 3 times 4x, what's that going to give me? So a minus 12x equals, we're not going to FOIL out here. What are we going to do? Distribute, I agree. You take the 3x times x, 3x squared, 3x times a negative 4 gives me negative 12x, I agree. And I see x squares, but something nice is about to happen. Let's suppose we try to combine all those x squares. I have an x square here and an x square here. If it's quadratic, we're going to need those x squares combined. Let's move this 3x squared over. What's going to happen when we do that? You have a 3x squared. I guess if you think of doing the opposite operation, you'll say a minus 3x squared minus 3x squared. What's just happened to the x squares? They are gone. So for this first problem where you're solving all the way, at least you're not going to have a quadratic equation. The resulting equation is just going to have x's. Any questions on what happened to those x squares? Let's clean this up a little bit. Here we have a couple of like terms. 4x minus 12x, what's that going to give me? 4x minus 12x is a negative 8x minus another 12x. What's negative 8x minus 12x? What's negative 8 minus 12?
Negative 20.
A negative 20x. And we still have something else on the left side. What is it? The minus 16. What have we got on the right side at this point? There's only one thing. That blue negative 12x. Any questions on my logic there? Or on the algebraic manipulation? 4 minus 12 is negative 8. Minus another 12 is negative 20.
Some people right here might have thought, oh, add 12x, plus 12x, plus 12x.
Yeah, that would have done it.
Oh, I'm getting
okay,
ahead.
now we need to get all the x terms by themselves on one side. I think I'll do this in a way to minimize the number of negatives popping up. I'm going to move this minus 20x over here and combine it with the negative 12x. So that's a negative 20x. When you move it over, what's it going to become?
Positive.
A positive 20. You're thinking to yourself, plus 20x, plus 20x. So you have negative 16. Negative 20 plus 20 is 0. You have negative 16 equals negative 12x plus 20x gives me what? 8x. And then to get x by itself, what do?
Divide by 8.
Divide by 8 to give us x equals negative 2. We multiplied by the least common denominator. We cross-canceled to cancel out every denominator. We solved the resulting equation. We just got to make sure that negative 2 doesn't give us a denominator of 0. It's hard to tell what the original denominators were. Look back at the original problem. What did y'all say the only number that would give us a denominator of 0 was in this problem? The first denominator would never be 0. The second denominator, okay. Did we get a 4 as our solution? So negative 2 is an acceptable solution.
If we had gotten 4 as the answer, we would have to click this, the empty set.
We would cross out, if we had gotten 4, we would have crossed out 4 and selected the solution as the empty set. Any questions there?
This sequential, a lawyer that works here at Del Mar, and she says every job interview she ever went to, they'd ask her, what did you make in college algebra? They wanted to know that grade because they want for law school or for lawyers to be able to think sequentially, follow when you're building a case in court. You're not just throwing the stuff up randomly. To build a case in court, you're going through a logical, step-by-step process. Okay.
Okay, switch over. If we have distinct denominators that can't be factored, then the least common denominator is the product of those denominators. That's what we saw in number 3. Here on number 4, we have 2 fractions, but are they distinct denominators? Are they different? Can they be factored? X minus 5. So what would be the least common denominator? Just x minus 5. If you have the same repeated denominator, your least common denominator is just that denominator that appears. The LCD It's just x minus 5 I'm going to. Oh, let me ask y'all something else while we're thinking about it. What number would be unacceptable as a solution? There's only one number that would give us a denominator of 0. What is it? 5. 5 minus 5 is 0. So let's just make a note here. X cannot equal 5. If we go through all of this and we get x equals 5, we're going to have to cross it out. Now here goes. We're going to multiply 3 by x minus 5, and I'm going to write it. We'll multiply the first term by x minus 5 over 1 equals, how many terms do we have on the right? How many times we're going to have to multiply by x minus 5 on the right-hand side of the equal sign? 2. There are 2 terms. A fraction's a term, and that's 6. So we're going to say multiply by x minus 5. That's 5 over x minus 5. Plus, we have a 6. Multiply it by x minus 5. Both of those terms have to be multiplied by x minus 5. Now we cross multiply and cancel out the fractions. In the first product, what's about to cancel out?
X minus 5.
X minus 5. Good. What are we going to be left with?
X.
Just the x. You want to cancel. You want the only denominators remaining to be denominators of 1. So we have x equals. The second product, what's about to cancel out?
X minus 5.
X minus 5. Maybe we should do this problem first from now on. This is working out very nicely. What are we left with?
5.
Just a 5 over 1. That's just a 5. Plus, what's going to cancel here? Is this a fraction? No, nothing's going to cancel, but we can remove the parentheses. What are we going to do to remove those parentheses?
Distribute.
Distribute to give us
6x.
6x, keep going, minus 30, I agree. Any questions there? Once you get to this stage, it's just the standard old solving equations. What's new is the way we're removing those fractions of those denominators. Well, let's see. We have a 5 minus 30. That's a minus 25, right? So we have a 6x minus 25. I just combined the 5 minus 30. That's going to be that minus 25. What do y'all think I'll do with this 6x? I guess maybe you'd want to move the x over and move that negative 25 over. Why would you want to do that? If I move this thing, that minus 25 over, it would become a positive. If I move that x over, 6x, that positive 1x would become a negative. So it at least get rid of the negative signs. Did y'all follow that? Or do y'all just want me to move the 6x over to the left? Y'all decide. Do I get the x on the left or on the right? It doesn't matter to me. You'll get the same answer at the end. I hope you're not one of those people with prejudices. You always want your x's on your left. So I think I'm going to do this. I'm going to move that minus 25 over to the left, and I'm making that a positive 25. I'm going to move this positive 1x over. That'll become a minus x. What's that going to give me? 6x minus 1x. What will I have here? A 5x. Any questions on our logic there? And then what? Divide by 5 to give us x equals 25 divided by 5. What did you say that's given us? 5. Is 5 an acceptable solution? No, we already said x can't equal 5. So what are we about to have to do to this 5? I'm going to cross it out. and say, no, there is no solution, you could sit in that chair for the rest of your life plugging in numbers for x, and you'll never get the left side to equal the right side.
They may not take that to be as significant a statement as I think that is. Wow.
There is
You
you
can
could-
plug every decimal, every fraction.
You could spend the rest of your life plugging in numbers for x, and the left side will never equal the right side. That's
Wow.
a very sweeping statement, I think.
Suppose I incorrectly type a 5 in here. I'm wondering if it's going to be smart enough to say, hey, wait, or is it
The
just gonna say
denominator is
wrong?
0.
No, they just use the LCD to clear the fractions. Finally, check the solution by, they say they substituted in the initial form. There. It didn't really know what was wrong.
Any questions there?
Can you explain again how you know
Switch back to
what number, like on this one, X, like how do you know that 5
Go
is
back
the
to the
number?
very first problem. Go back to the first problem we did today. We're asking ourselves, what number can't be 0? You take any, look at that number 1 right here. Any denominator can't be 0. X minus 5 can't be 0. And you solve for x. Isn't x minus 5? You went, there's only one denominator. X minus 5 cannot equal 0, so x cannot equal 5. You're remembering that denominators can't be 0. Anytime you have a denominator, you need to make sure that the solution you get doesn't give you a denominator of 0.
Okay.
Suppose we had solved this and gotten x equals 7. Would 7 have been okay?
Yes.
Suppose we had solved it and got 60 million. Would 60 million be okay?
Yes.
The only number that would have been an unacceptable solution would be 5, because 5 is the only number that gives us denominators of 0. You're checking to make sure the denominator, how did I write that when I was writing out those steps? That last step. Cross out any solution that gives a denominator of 0. If you took that 5 and plugged it in right there, 5 minus 5 is 0.
And right here too.
Same thing there. Any other questions? Well, so far these things have been linear. That can't continue. We're going to have to start getting some quadratic equations to solve. Let's look at number 5. Let me write this down. Uh-oh. 3 over x squared minus 44 over x is equal to 15. Okay. 3 over x squared minus 4. Okay, switch over.
Get this copy.
We have monomial denominators here. It's not an x plus 5 or an x squared minus 4. It's just single terms. I claim we have repeated factors here. Here we have an x to the first power. Here we have an x squared. Well, what would the least common denominator be? The most common mistake is that people decide that the least common denominator is just an x. That's the most common mistake. People decide the least common denominator, you have repeated factor of x, you have an x squared and an x to the first, they'll try to just use an x. If you use just an x, will you cancel out that entire denominator? If you try to multiply, here's my scratch paper, x over 1 times 3 over x squared. Are you going to cancel out the entire denominator? You can cancel an x above and below, but what have you still got down there in the denominator? You still have an x. If you have repeated factors with different powers on them, your least common denominator, you use that factor, but use the largest exponent that appears. So x squared. You're going to be multiplying by an x squared. If you just use an x, you're not going to get rid of both of the x's in this first fraction's denominator. Any questions there?
Or maybe
So-
they'll do it the way Gibby's teacher did.
We don't have time for that.
Okay.
Okay. X.
Mm-hmm.
Oh,
Oh,
x
sorry.
squared over
Oh.
1
I was just stretching.
Oh,
Oh,
okay.
Sorry.
minus.
Oh, that's fine.
Oh, I did ask y'all, how many times are we going to have to multiply by x squared? How many distinct terms do we have? How many terms do we have on the left side of the equal sign? 2. How many on the right? 1. So that means we're going to have to multiply a total of how many times? 3 times. The first term gets multiplied by x squared. The 44 over x is going to be multiplied by x squared. And the 15 is going to be multiplied by x squared. Notice I don't put it over 1 here because there's no fraction. If I'm multiplying the LCD by a fraction, I put it over 1 to make sure it's clear. You cancel top with bottom. And here goes. The x squares completely cancel out, leaving us just a 3 as our first term. Now the second term, what's going to cancel? That 1x above and below. So we've canceled that x. We no longer have 2 x's on top, but we still have an x left over. We have x times 44. I'll write that as 44x. Any questions on my logic there? Equals. Is anything going to cancel on the right? There are no fractions, so you're just stuck with a 15x squared. Any questions there?
So this one is quadratic.
This one's going to be is quadratic. We have an x squared, and it's not like that number 3 where all the x squares canceled out. There's no other x squares. We need it set equal to 0. Also, we need the x squared coefficient to have what sign?
Positive or negative?
Positive or negative? If I pick this 15x squared up and move it to the left, what's going to happen to that 15? That's going to become negative. So you want to leave that where it is. I'm going to get the 0 on the left side. We have a 15x squared. Now move the x term over. What's that going to become?
Positive.
A positive 44x. The negative 44 became a positive 44 when you moved it over. What about this 3? Move it over. What's it going to give us?
-3.
Negative 3. And it's quadratic. I believe it's factorable.
Hey, your little.
I know it's going to work, isn't it? 15. There are 2 pairs of positive integers. 1 times 15 or 3 times 5. For 3, there's only one possible pair of factors. What is it? 1 times 3. So we have a 0 on the left. I'm writing my 2 sets of parentheses. And this is one of those chances for me to show off that I'm pretty good at factoring. I have this little trick that works a lot of times. If you multiply that first number by the last number, 15 times 3 is 45. If that number there in the middle is either 1 more or 1 less, then don't try the 3 and 5. Try the pair that includes the 1. And I think that's what we're going to need. We're going to need a 1x and a 15x. We'll use a 1x and a 15x.
First time I ever
didn't
heard you
ask y'all.
state that little rule, I was shocked. I was like, where the heck did he come up with that? But yeah, you're right.
The last sign's a minus. I didn't ask y'all this. I should have asked y'all at the very beginning. If the last sign's a minus, what do we know about the signs inside the parentheses?
plus and minus.
We're going to have one plus and one minus, and we're going to wait to fill that in. I'm going to make a note right here. We're going to use a plus and a minus. Now, we're using 1 and 3. Hey, this is really nice. Can I put the 3 here? If I put 3 there with the 15, aren't they both divisible by?
Well,
I think they're
yeah,
divisible
3.
by 3,
But
okay? Because 3
15
times
divided
5.
by 3 is 5, huh?
But you can't pair the 3 with the 15. Do y'all follow that logic? I don't have a pencil. If I did, oh, here it is. If I put the 3, if I put that 3 there, 3 and 15 are both divisible by 3. That can't be correct.
Only
So,
common factor you can have is a 1.
only common factor you can have inside those parentheses is a 1. So we better put the 3 there and the 1 there. Oops, a 1 right there. Let's check the outer and inner. What's my outer product?
1.
1x, x times 1 is 1x. What's my inner product?
45.
45x. We need these things because of that minus sign. We need them to subtract to give 44. Can you subtract those to get 44? 45 minus 1? Sure, that gives you a positive 44. So that's the correct placement. The question is, where do we put the positive and where do we put the negative? We want a positive 44x, so that means 45 needs to be positive minus 1x. 45 minus 1, doesn't that give you a positive 44? So where do you put the plus to get a positive 45x?
3.
Should the plus go? Yes, it should go with the 3. Positive 3 times 15 gave you that positive 45, which means we have a minus right there. Set each factor equal to 0. Set x plus 3 equal to 0. Set 15x minus 1 equal to 0. That says that x equals, here, negative 3. This one, we need to get that constant over on the right-hand side. So what are we going to do?
Positive 1.
Okay, so we're going to have a 15x equals a positive 1, and then
You have to
divide
divide 15
by 15, I agree, to give us x equals 1 over 15. I did even ask y'all, I was too enthralled with the fact that we just had repeated factors with different exponents. I'd even ask y'all, what number would be unacceptable? It's easiest if you just look at 44 over x. What would you have to plug in for x to get a denominator of 0? What? 0? X can't equal 0. Did we get a 0 as our answer? No, so both of these answers are acceptable solutions. Any questions there? Yes.
Is that a decimal on the under 45 plus? Is that
45. where?
1 times. It's a dot. for
It's a dot.
five.
I just have a dot. It's
Oh, wait,
no,
right here?
Right,
That-
you mean right here?
Yeah.
No,
Oh, no.
those are just my
Your pen
my
touched.
pen touched and made that dot. There are no decimals. It's a 45 minus 1. That gives us a, oh, I'm making more
Hold it
dots.
like that.
That gives us a 44.
Yeah, covered it up.
Any other questions?
So negative 3 and 1 over 15. Let me catch that in. Negative 3, comma, 1 slash 15. Okay.
Mm-hmm.
Mm-hmm. You ready for the next one?
Yes. Oh, oops.
Did you just...
I tore the page.
Oh.
Okay, we have the fraction 2x minus 7 all over x is equal to x minus 2 all over 5. 2x minus 7 over x is equal to x minus 2 over 5. Before I forget about it, this denominator's a 5. It'll never be anything else. It'll never be 0. But this denominator has a variable. What can x not equal? What number would make that x equal 0? It should be obvious. What's the only number you can plug in down there and it be 0?
0.
0. So x can't be 0. It's just like that previous one. If we go through and we get x equals 0, we'll have to cross it out. But anything other than 0 is fine. Notice we have two distinct denominators. Can those denominators be factored? No, they're monomial terms. X is just x and 5 is just 5. So the least common denominator would be the product. Using that rule that we saw, that we used in problem number 3, two distinct denominators that can't be factored, multiply them for the least common denominator, but I'm not going to do that. When you have one fraction equals one fraction, that's called a proportion. I guess the name doesn't matter. The name doesn't matter. And there's a way of solving proportions that you may have seen. It involves crossing something or another. Who remembers how you solved proportions in previous math classes? And if you don't remember, I'm going to show you right now. Do y'all remember a phrase called cross-multiplying? You can cross-multiply. You take the denominator of the numerator on one side times the denominator on the other side, then the denominator times the numerator.
Now, why didn't you do this on the previous one?
Have we had any proportions? One fraction equaling another fraction. Could we do it on number 14? I see we have number 4. We have one fraction equals. We don't just have another fraction on the other side. What else do we have? That plus 6. You can only do this if your equation's in the form fraction equals fraction. You take the 2x minus 7 times 5. 2x minus 7 times 5. What are we going to have to do there to perform that multiplication? Take the 5 times the 2x minus 7 equals, you take the x times the x minus 2. So now I'll ask the question again. What are we going to do to perform that multiplication? What are we going to do to multiply 5 by 2x minus 7?
Starts with a D.
Distribute. So you're going to get a 10x minus 5 times 2x gave me the 10x. What else am I going to have right here? 35. 5 times 7, so we have a minus 35 equals. I'll let you tell me what we have on the right-hand side. X squared, okay, x times x is x squared minus 2x. We distributed the 5 there and there to get the 10x minus 35. We distributed the x there and there to get x squared minus 2x. And I want to make a note. I'm seeing dots here where I'm touching my pen. There are no decimals in any of the problems in this assignment, okay? The only time I have a period is usually after the problem number.
There might not be any decimals till the end of the last assignment this semester.
Oh, there might be. Okay. I see x squared. That means it's quadratic. We're going to have to get it set equal to 0. Where do y'all think I'm going to get the 0? On the left side or the right side? The left side, because if I move this x squared over to the left, instead of having a positive 1 as the coefficient on x squared, what am I going to have over here? and negative 1x squared. Remember, you want the coefficient of x squared to be positive. That makes things much nicer. So we have x squared. Let's move that 10x over to the other side. What are we going to get? We want a 0 on the left side. What are we going to do to get that 10x over on the other side? You have a negative 2x, and what are you going to do? That's a
Minus 10x?
positive 10.
Minus
So the
10x.
minus 10x, negative 2 minus 10 gives me a negative 12x. I'm hearing someone in the peanut gallery answering correctly. Speak a little louder. You know I'm hard of hearing.
I think you've just convinced him to shut up and not say anything the rest of the semester.
Oh, no. Okay. What am I going to do with this minus 35? Add it, okay. And it's another simple trinomial where it's just an x squared. That's great. It's easier to factor. I say another simple trinomial. Have we seen a simple trinomial today?
I don't think so.
No, I don't think so. X squared. The only possibility, 1 times 1, so 1x times 1x. We're finally getting a break on our factoring. What do we know about the signs? We know something definite here.
We're gonna-
If the last sign's a plus, you're going to have negative at times a negative. If the last sign's a plus, you have 2 of the first signs. And for 35, what times what equals 35? There's only 2 possibilities. 1 times 35 and 5 times 7. With a simple trinomial, you choose the pair that adds together to give you 12. Which pair here adds together to give you 12? 5 and 7. Set each factor equal to 0. And we're going to get 2 possible solutions. What are they? The first one, x equals 5. You move the 5 over, change the sign. What about the second one? Move the 7 over to get x equals 7. Any questions up to this point? Y'all are sure getting quiet.
Keep in mind, Wednesday will be a better day.
Do we have to cross any of these numbers out? Will either of those numbers give us a denominator of 0? What did we say the only number that was unacceptable was? 0. Did we get a 0? No. So 5 and 7 are both acceptable solutions. Any questions there?
5 and 7. 5, comma 7.
Any questions?
Whatever you're typing in the solution set, doesn't matter which one.
It does not matter, okay? Once we get to solving inequalities, it's going to matter. You'll have to go small to large. But for this
You'll
here,
know when we
because
get there.
really, if you think about it, I could have put x minus 7 times x minus 5 and gotten 7 and then 5. So the order of the solutions, as long as you have the correct numbers, the order doesn't matter.
For this.
But once we get to inequalities, and I'll be telling you, you got to go small to large, okay? Any questions there? And now we're ready for radical equations.
These are equations that have a...
By radical
Root.
equations, I mean equations that are, switch over to my paper.
Oh, wait. One more.
Radical equations, those are equations with square roots and cube roots. Collectively, we call all those symbols radicals. These are not, it's not like a radical terrorist or something, just meaning bizarre or something. Radical equations are equations that have square roots or cube
Okay.
roots. Equations
An equation has an equal sign.
with square roots or cube roots or fourth roots,
Got it.
any sort of roots. And we're going to see cube roots and fourth roots in this assignment as well.
And I'll give the pep talk. They're going to turn out to be easier than the square roots. The square roots are the messy ones, oddly enough.
At the beginning of the semester, when we were working with square roots, we made this remark here, okay? The square root of x, when you square it, reduces to what? If you have a square root times itself, what does that reduce to? What does that square, what impact does that square have on that radical symbol? It just eliminates it, leaving us just an x.
Square root and a square cancel each other out.
When they're performed consecutively like that, squaring a square root cancels themselves out, leaving us just the radicand. Suppose we had a cube root. Couldn't just square it to get rid of it. If it's a cube root, what power do you think would eliminate a cube root? A cube, I agree.
Mhm.
And in general, we say that if you have the nth root, it could be a fourth root, it could be a square root, it could be a 50th root, who cares? The nth root of a for anything, when you raise it to the nth power, whatever that little number there, like that 3, that's called an index. If it's a 2, you don't show it.
But you say it.
But you say it's square root, and now the nth root, when you raise it to the nth power, you're left with the radicand, whatever's underneath there. Now, we know that when solving equations, to maintain the balance, whatever you do to one side, you got to do to the other side. To maintain the equality, whatever you do to one side, you got to do to the other side. If you have a square root and you want to square it, you're going to have to square both sides of the equation. Now, I want to look at this. Let's suppose we had the square root of x plus 7 all being squared. As long as everything is under the square root, that square will undo the impact to that square root, leaving you just the radicand, x plus 7. As long as everything's under the radical and you're squaring a single radical, things are fine. You've eliminated the radical. Let's look at this one here. Suppose we have the square root of x, and the only thing under the radical is that x. Suppose you have a plus 7 stuck on there that you want to square. Oh, this is bad. Squaring this stuff is not going to eliminate the radical. We looked at how you square a sum or difference. I know we did it in the second assignment with complex numbers. If you have a sum or difference being squared, say a plus b quantity squared. You don't just square a and square b. Do y'all remember? I think we had something like 3 plus 2i, and it was squared. What did we do to square that complex number? If you have a
Four-letter word that starts with F.
We'd have to write it twice. Do I remember doing this in the second assignment? The problem is we had that whole week off after the first week. Do y'all remember? If you have a sum or difference, you have to write it twice and then FOIL it out. So here, we have to write it twice. The square root of x plus 7 times the square root of x plus 7. I am going somewhere with all of this. I'm not just rambling.
If you were rambling, I'd stop you.
So we'd start FOILing. The square root of x times the square root of x. That's the square root of x squared, and we know what that is. That's just x. Outer, the square root of x times 7, that's 7 times the square root of x. Plus, y'all tell me the inner product right there. You take the 7 times the square root of x, what's that going to give us? 7 times the square root of x. And last, 7 times 7, what's that going to give us? Okay. Have we canceled out all the radicals? We took the square root and we squared it. Have we eliminated the radicals the way we want to? What's 7 square roots of x plus 7 square roots of x? Did those cancel out? 7 plus 7 is, I remember adding radical terms during the first day, during that first assignment, and we said they'd have the same radical part. They do, the square root of x. And then you add or subtract their coefficients. 7 plus 7, that's 14 square roots of x. Did we eliminate the radical by squaring?
No.
Not only did we not eliminate the radical, we picked up a bigger number. We have
Looks a
another
heck of
x
a lot
term. I
worse.
think this looks even worse. Do you agree? You can't just start arbitrarily squaring and eliminate radicals. If you're not careful, you may start squaring and get something much worse than what you started with. So my point is, before you start squaring both sides of the equation, you need to make sure that your radical is isolated. If you have more than one radical, you got to get one of the radicals isolated. So if you had something like this, that plus 7 would have had to been moved to the other side before you start squaring both sides. I'm going to say important. Before squaring both, I'll say before raising both sides of an equation to a power, if it's a square root, you'll square both sides. If it's a cube root, you'll cube both sides. But before you can do that, before raising both sides to a power, you must first isolate a radical term. I'm running out of room.
Now, if there's only one square root in the problem, isolate it. If there were two, well, isolate one of them. And it's usually pretty obvious which one you would, how you move them around. But
Before you start to raise both sides to a power, you have to isolate a radical term. And once I isolate that radical term, I'm not going to look back at the original problem. So, oh, and there's we have an added wrinkle to all of this. Raising both sides of an equation to an even power does not guarantee equivalence. Now, what the heck does that mean? Okay. I think y'all will agree. You know, a negative times a negative is what?
Positive.
Positive. So I think that y'all agree. Consider this. 3 squared is the same thing as negative 3 squared. Aren't they both? What does 3 squared equal? 9. And what's negative 3 times negative 3? It's still 9. Let's go back and drop the squares. If we drop the squares, do we have a true statement? If we don't have those, if we drop those squares, it says 3 equals negative 3. Does 3 equal negative 3? Raising both sides to an even power, you may wind up with a solution that isn't really a solution. Because when you're going through squaring both sides, you may be taking something that's negative and changing it accidentally so that it's positive. So once you're through solving the equation, you're going to have to go through and verify that if you plug those numbers in, the left side equals the right side. And why is that? It's those even exponents that people like square roots more than cube roots. Cube roots get a bad rap. Cube roots are great If you cube a negative number, does it become positive? Negative times negative times negative. Is that positive? No, it doesn't change signs. Odd exponents and odd indices, those are the great ones. Those are the easy ones to work with. It's those even exponents that cause problems, because when you're squaring both sides, you may accidentally take something that's negative and change it so that it's positive. I've rambled enough. I'm going to write out a little process we're going to use to solve radical equations. I'm going to write.
I've been timed out on this.
I hope not. To solve radical equations, the first thing we're going to do, isolate a radical term. If you have more than one term containing a square root symbol or a cube root symbol, you have to get one of them by itself. I'll say isolate a radical term. I'll just say isolate a radical. And then 2, raise both sides of the equation to whatever the index is on the radical. If it's a square root, you're going to have to square both sides. If it's a cube root, you're going to cube both sides. I'll say raise both sides to the index. I think that's the shortest way of saying it. Raise both sides to the index. If it's a square root, you raise both sides to the second power. If it's a cube root, raise both sides to the third power, and so forth. If you do this correctly, no radicals should remain. I'll say simplify. If a radical remains, you'll have to repeat the process, but at this point, hopefully you won't have any radicals remaining, so you'll solve the equation. It'll either be linear or quadratic. Most of them, I think, will turn out quadratic, and you'll be able to factor them. If you can't factor them, then what do you use? If you don't see the factorization, how do you solve a quadratic equation? What's your go-to method? The quadratic formula, right. And here's the 5th thing. You are going to have to check your solutions for equations that were raised to even powers.
For even.
I'll say check solutions for even roots.
Square roots.
Square roots, 4th roots, 6th roots. If your equation had a square root or a 4th root or a 6th root, you're going to have to manually plug your numbers in and make sure the left side equals the right side. Now, for cube roots, you don't have to check them. Cube roots don't change. When you're cubing, you don't change negatives to positives. It's squaring and raising to 4th power that gives you the problem, because even powers change negatives to positives. If you have a negative to an even power, it becomes positive, and that's the problem right there.
That causes a lot of trouble. But let's do number 8.
Okay, let's do number 8.
Let me see. I'm going to click and make sure. Okay.
Number 8. Well, maybe select there is no solution and have it timed as if, so they'll start the timing over. I don't want to be timed out. There is a solution, I'm sure of it, but just
you mean put it wrong?
Yeah. Okay, go back.
It's just to make
otherwise, it's minus the square root of 24 minus 2x. Let me make sure I haven't miscopied, okay? Let's switch over to our work.
Oh, I like it when you have those steps right there.
I had to write small. Oh, goodness. Okay. The first thing we do, isolate a radical term. There's only one radical term. There it is. We need that radical term by itself. There's a smart thing you could do to get that radical term by itself on one side. What's the smart thing to do? I couldn't hear you. Okay, I could do that. I could get rid of the x, but I'm still don't have the radical by itself. I'd have something else there.
Negative.
What would I have there left? I think I'd add the radical. Good. Notice, even if we move the x over, we're still going to have that negative sign there. Well, once we square it, it'll become a positive, but it's just added hassle. The smart thing to do is pick this radical up, move it over, and when you move a negative over, what sign does it become? Positive. So you have x equals the positive square root of 24 minus 2x. Okay.
So you've done step one.
I've done step one. I've isolated the radical. Now, these are square roots, so what power am I going to have to put on both sides? What power eliminates a square root? I couldn't hear you. A square, we're going to square both sides. There and there. So we can simplify. This simplification, I don't think we're going to have a radical remaining, are we? We have x squared equals, what have we got on the right? The square undoes that square root, leaving us just a 24 minus 2x. Good. It's quadratic. That means we need to get it set equal to 0.
How do you know it's quadratic?
How do I know it's quadratic? That's a good question. What do I see that says it's a quadratic equation? The square. You have to have the variable square. That's what makes it quadratic. Well, if we're solving it, whether we solve it by factoring or the quadratic formula, we need one side set equal to 0. Where do you think I'm going to get the 0? On the left side or on the right side? On the right side, because if I pick up this x squared and move it to the left, that positive 1x squared, when you move it over, becomes, when you move something that's positive over, it becomes
Negative.
And you don't want a negative leading coefficient. The coefficient of the square term should be a positive number. So I'm going to move these things over. That'll give me an x squared. What comes next? Plus 2x, I agree, and minus 24, good, equals 0. It's a simple trinomial, x squared. Now remember, a simple trinomial is one where it's just a 1x. The leading coefficient is just 1. It's simple to factor it in that case. You don't have to worry about different pairs for the first term. What times what gives you x squared? X times x. What do we know about the signs? This thing couldn't have been positive. If that last sign had been positive, to me that's the easier case. What do we know about the signs? If the last sign's a positive, we have
Sure, the plus, if the last sign's a minus.
If the last sign's a minus, you have a 1 of each. If it's plus, you have 2 of the first. If it's a minus, you have 1 of each. Now 24. What times what will give you 24?
1 times 24.
I'll get us started. 1 times 24. Then 2 times 12. What else?
3 times 8.
3 times, oh, I think it's 3 times, oh yeah,
Yeah,
3
3
times
times
8, you're right. Okay, 4,
Times 6.
4 times 6, 5. Does 5 divide evenly? 6, you've already backed to 6. So you've got every possible combination at this point. There's 4 of them. Which one will you use? With a simple trinomial, you choose the pair that subtracts to give you a 2. Which pair subtracts to give you a 2? 4 and 6, so we're going to have a 4 and we're going to have a 6. Now be careful. Think about the signs. You want to get a positive 2x. So where should the plus go? Should the plus go in front of the 4 or should it go in front of the 6? It should go in front of the bigger one, the 6, since you want the result positive. Did you follow our logic there? The outer product is a 6x minus 4x. That gives us the positive 2x. Any questions on that factorization? The programmers are nice here. When you do number 8, even though the numbers are going to be different, it's going to be a simple trinomial. You'll wind up with an x squared. Even though y'all's problem will be different, they're going to make sure the number 8 is going to wind up with a simple trinomial. So people that say, oh, this program, they don't like it because they can't control the numbers. Yeah, you can't. I'm stuck working this problem here, but they know, okay, be reasonable and make it a simple trinomial to factor, and that's what they've done. Set each factor equal to 0. So I've simplified. I'm solving the equation. What am I going to get as my solution? Here, what will I get?
4.
X equals 4. Move that minus 4 over. It becomes a positive 4. And here, what are you going to get? X equals negative 6. They want us to realize we had an even root. We had a square root. So we're going to have to manually check our work. Here goes. We have two numbers, 4 and negative 6.
And Tim had a little trick that I'd never, when we started teaching together, I was like, oh, wow.
Okay.
No,
You learned all of my secret tricks, Tony,
Uh-huh.
and I learned yours.
yeah, you
okay?
know mine, yeah.
Okay, so my advice to you when it comes to check in the format where the radical is already isolated.
Okay.
Remember, you moved that over. I should have had a separate step here. I will in the next one. Don't use the squares. When you moved that radical over, the equation said x equals the square root of 24 minus 2x.
So your little trick is it's easier to check it
If you use the isolated form.
Mhm.
Don't go back to the original problem and plug in. Use the isolated form. Here it is. Let's get started with 4. Plug 4 in wherever you see a variable. So you have 4 equals the square root of 24 minus. What's 2 times 4? What am I going to have here? I couldn't hear you. 8, okay. When I say I can't hear you, I really can't hear you.
Well, if I hear
I'm
him,
not
I'm going to
deep.
just start saying.
Oh, okay, you do
I
that.
have that.
You're talking to my good ear, okay?
Okay.
Okay.
She's
And
joking.
24 minus 8 is?
No, I haven't heard anyone say that.
Do y'all see where we
24
got the
minus
8? Yes. 24 minus 8 is 16. So I guess the question is, there's a little question mark. Does the left side equal the right side? What's the square root of 16?
4.
Does 4 equal 4?
Yes.
Yes, it does. So 4 checks. So 4 is acceptable. What about negative 6? Let's plug in negative 6. I'm going to start. Plug in negative 6. Look at what I'm about to do. Negative 6 equals the square root. Wait a minute. This doesn't work. Look at the square root. I don't see a sign there. What sign is there? If you don't see a sign, what is it? Positive? Can negative 6 equal a positive number? It doesn't. The rest of it doesn't matter. Can negative equal positive? That's what I'm asking. Can a negative number equal a positive number? No. And this is going to be important because sometimes you're going to have to cross out negative 6. Suppose that had been a negative 1/6. This pops up along the way. You have something like a negative 1/6. You plug in the negative 1/6 equals. That'd be a mess plugging in negative 1/6 to check. But you don't have to, because if you have the radical isolated the way I do, it'll always be a positive. So if you're trying to check something that's negative, you can see right off the negative will not equal the positive. Any questions there? The only acceptable solution is 4. Any questions? We isolated the radical term, we raised both sides to the index power, we simplified and solved the equation, then we had to check. Now in a little bit we're going to get to a cube root equation. Are we going to have to do this last step here for the cube root equations? Do we have to check cube roots? No, you only check them for even roots. If you raise both sides, you see we raised both sides to the power 2. Is 2 an even number? Yes, so you got to check it. And why do you have to check it? Because you may have taken a negative number, raised it to that even power, and accidentally got an incorrect positive result. That -6, we shouldn't have even gotten that, but it was a result of the way we changed some negatives to positives. Any questions there? Number 9. Okay. Oh, okay.
If you can make it through this problem,
In
then
my opinion, if you make it through this problem, everything else in the homework is better than this one. I guess we could just start saying similar question or help me solve it to get better numbers, but my experience is it doesn't matter. This number 9 always has messy numbers, okay?
I think the programmer was having a bad day
Yeah.
when he wrote the code.
When he wrote the code for this problem, he was like, I'm
But
going to
it's such a
show
good
her.
problem.
But it's a good problem, okay? Let me make sure I didn't miscopy it.
So you're
minus. I'm hungry. Oh, goodness. Okay. There's only one correct first step. What is it?
So we have a square root. And
We
what
have a
do we
square
need to-
root.
show
What are
them
we
your
going to
little
have to
step.
do? Okay. Isolate the radical. How are we going to isolate the radical? We want that square root by itself. There's only one correct first step, in my opinion. What is it? Add the 8. Get the radical by itself by moving that -8 over. So it becomes a positive 8. So you have the square root of 9x plus 63 is equal to, we have a 2x. What else do we have? We have the 2x. What's -3 plus 8?
Plus 5.
Plus 5. Have we isolated the radical? Yes. Put a little asterisk there. This is what you're going to use for checking.
Do we have to check it?
Do
How
we
do
have
know
to
we're
check
gonna
it?
have to check
Yes.
Yes, because it's a square root. What power am I about to use to get rid of that square root?
Square.
The square, 2 is an even number, so you got it. You're going to have to check it. And I'm going to make an extra step here. So we have the square root of 9x. I'm not just going to stick the square on it the way I did a moment ago, because I want to be able to clearly see this line here. That's the thing we'll use for checking. That's the format that we'll use to check in a moment. Okay. So we're squaring both sides. What will the left side give us? Okay, so that square undoes the radical. You're left with that stuff underneath there, 9x plus 63. What are we going to have to do on the right? It's a sum being squared. It's not just 4x squared plus 25. If you have a sum or difference squared, what do you have to do?
It's Starts with the F, four-letter word.
Foil.
Foil it out. You got to write that 2x plus 5 twice. Oh, I've got another decimal point floating around here. It's just where I set my pen down. There are no decimals in this homework. Here we go. First, 2x times 2x. That's going to give me 4x squared. Outer, 2x times 5. That's a plus 10x. Inner, 5 times 2x gives me another 10x. Last, 5 times 5 is, so we have a 9x plus 63 is equal to, we have a 4x squared. 10x plus 10x gives me a plus 20x, and I still have a plus a 25. It's quadratic. Well, let me take a drink. Take a peppermint. Why don't you open it real slowly so we can hear the creaking real slowly? Next time, Tony, let's open several of them, and we'll have them already opened before we start. Oh, does it?
Oh, that sounds sort of gross. You
No.
open it before you eat it.
Okay. Y'all caught up with me?
Which side do y'all think we should get 0 on?
Should I get 0 on the left side or on the right side?
Left side.
Look, I'm going to get it on the left side because if I try to move this 4x squared over, what am I going to get?
Negative.
A negative, and I don't want a leading coefficient that's negative. So I'm going to move the 9x. This problem's so messy, I'm trying to show steps that I don't normally show. So we'll subtract 9x from both sides. What are we going to do with the 63?
Negative.
Okay. Oh, goodness. To give us. So now we'll have a 0 on the left. We have a 4x squared. 20x minus 9x gives me a plus 11x. And 25 minus 63, is that a negative 30? 38. I guess that's not that bad. Any questions?
How do we know we're going to have to factor this? Or use the quadratic? Well,
How do you know that we're going to either have to factor or use the quadratic formula? Because of that square, that's right. And I want to stop right now and show y'all something. Last year, last semester, when I did this problem number 9 for the class, let me show you the equation we got. At this point, instead of 4x squared plus 11x minus 38, we got 4x squared minus 47x plus 99. Okay, so I was trying to show y'all, if you get some big messy quadratic equation and you don't see the factorization, go to the quadratic formula. You'll want to have your calculator with you, but it's still doable. Now, I'm sitting up here, and for me, it doesn't sound too bad, look bad at all, because 4x squared is either 1 times 4 or 2 times 2, and 38 is either 1 times 38 or 2 times 19. 2x and 2x, that's what most people would want to try. That cannot work. If you use 2x and 2x, you're either going to be pairing a 2 with another 2, or you'll pair the 2 with the 38. Either way, you can't have 2 even numbers inside parentheses. So I'm able to discard that 2 and 2 very quickly. Did y'all follow my logic? If you try to use 2x and 2x, you're either going to pair the 2 with this 2, or you're going to pair the 2 with the 38. Either way, you're going to pair the 2. You'll either pair it with say the 2 and the 19. No, can't do that. Or you're going to wind up pairing the 2
No. Oh, wait.
with the 38. Either way, if it's factorable, and the reason I know it's factorable is because the instructions didn't say, hey, use the quadratic formula. If you run into a quadratic equation in my math lab and it's not factorable, they're going to tell you, use the quadratic formula. They're nice. They're not going to make you sit there for 4 years trying to get something factored that isn't factorable.
Same for the exam?
The same thing, the same instructions on the test or, on the homework are used in the exam. So it's going to have to be 1x and 4x. Hey, what do we know about the signs? The last sign's a minus, so 1 plus and 1 minus. And let's see.
That 11
How about,
is pretty small. I
yeah,
would've
that 11.
thought-
I'm not going to use 38 because that number there, 11, isn't that big. I think we're going to need the 2 and the 19. If I'm going to use the 2 and the 19, can I put the 2 there?
No.
No, I'd have to put the 19 there and the 2 there. This does it. Let's check the outer and the inner products. The outer product, x times 19, that's a 19x. The inner product right there, 2 times 4x, that is 8x. You need it to subtract. That last sign tells you whether you need it to add or subtract. You need these numbers to subtract to give you 11. Can you subtract these numbers in a way that you get 11? Yes, 19 minus 8 gives you 11. Now, what needs to be positive? In order to get a positive 11x, what should be positive, the 19 or the 8?
19.
That needs to be positive and that needs to be negative. So to make the 8 negative, we better put the minus there, the plus there.
Do y'all follow that? There's a lot of thinking going on here.
Everything we've done this semester, from radicals to solving equations, it's all coming into play in this one assignment. Any questions before we go on? We're not finished. Now that we've gotten it factored, what do we have to do?
X minus 2.
Okay, so set each factor equal to 0. Set x minus 2 equal to 0. Set 4x plus 19 equal to 0. That's going to give me x equals here 2. And this one here, we have 4x equals a negative 19. Then divide by 4 to give us x equals negative 19 over 4.
Well, we're going to have to check this.
What do y'all think? Do we have to check these?
Yes.
Yes, because we've raised both sides to an even power. Well, here, and remember, I said check in the form where it's isolated. That square root of 9x plus 63 equals, what was it, a 2x plus 5? So, and let me write it here also. Square root of 9x plus 60. Okay,
Just a
I'm
little.
running out of room. Okay. We don't need that original equation anymore. We need that one where it's isolated. That's what we're checking. Plug in the 2. 9 times 2 is 18. So we have an 18 plus 63. 18 plus 63, well, 20 plus 63 is 81. So we have the square root of 81 on the left side.
Which is what?
What's the square root of 81? 9, okay. Plug in the 2 here. 2 times 2 is 4 plus 5 Does the left side equal the right side? Yes. So 2 is an acceptable solution. We'll circle 2. The next one you might want to dig out your calculator with. I'm plugging in -19/4.
This might be a good time
This might be a time to
convert it to decimal.
It might be a good time to think the way I did with that previous one. I'm not going to bother with this radical here. That radical, what sign do we have? I don't see a sign, so we assume the left side is what?
Positive.
Positive. So here you go. Plug in. You have a 2 times -19/4 plus 5. Show them how you would check it on a calculator, Tony. Oh, look at that. It gives us -19/2 plus 5. That's -19/2 plus 10/2. -19 plus 10 is -9/4. It's going to give us a -9/2. That's going to give us a negative result. Can a negative equal a positive? Mm-mm. Look at that. Look how Tony punched that in there. That stuff gives us a -4.5. Can a positive result equal a negative result? And how do we know the radical has to be positive? Because the sign there, what sign do you see? You don't see a sign, so you assume it's positive. Can a positive equal a negative? What do y'all say to that? Is that okay? No, it isn't. Cross it out. The only acceptable solution. Yeah, all of this page here. Let me see. I need to put there and move it there. Okay. All of this just to get the solution 2.
Let me punch that in.
I'll say no there.
I still missed the original problem, but
Let's see. How about there?
yeah. Keep going up. Oh, wow.
Yeah, that's about as good as we're going to get it. Well, maybe I could go up a little more.
I'm going to reluctantly say, any questions?
Any questions?
Looking at
For
this
what
finished
it's
product.
worth, in my opinion, this is the worst it gets in this class. In terms of the problems, number 9 on assignment 6 is my least favorite problem in the course.
But we got pretty lucky with numbers. I
We
guess.
did.
Didn't
Y'all,
wind up
you
with
don't
a
realize
9.
it, but we got lucky with the numbers here.
Okay.
That 4, only 2 possibilities,
Well,
we got lucky.
Let's go on to the next one. Oh, no. Which one are we doing now? 11?
11, and I'm going to take this chance. My voice is gone. I'm going to take this chance and we'll switch.
Oh, my goodness. So, let's see. Oh, wait.
We're doing 11.
Oh, okay.
Now you get to do the easy one.
After I've had to do this.
Cube roots are a lot harder than square roots, Tim, so don't be complaining.
You know
I'm
that's not
joking.
true.
Yeah. Okay. How does number 11 differ from the ones we've been doing? Well,
There's a big fundamental difference. What is it?
So,
Are we going to square both sides? We're going to have to cube both sides. Are we going to have to check our answers at the end of the problem? No, we're not.
okay. Can flip over here so I can show this. You only have to check your answers for even roots, square roots, fourth roots. No cube roots. Cube is the number 3. That's odd. And I should have already written down this problem, but I didn't. So, Tim, you want to put it back?
I guess so.
The
I'm ashamed to
cube root-
say I've been talking so much, I'm winded. There was a time in my life I wouldn't have gotten winded from sitting down talking for an hour straight.
You're
over an
old,
hour.
Tim. You're
I'm
old.
old, thank you.
Okay.
That's right.
There. There's only one correct first step on this one. Cube root of 3x plus 6,
No, plus 9. Oh,
No,
three.
plus
Oh, you're
6.
3x plus 6. Okay.
And then plus 9 equals
You
4.
got it written down correctly. Oh.
What are we going to have to do first? We need to read the steps. Isolate the right. There's only one radical, so that's the one we're going to isolate. Only one correct step. What is it?
Minus 9. I agree.
Let's subtract 9 from both sides. So we have the cube root of 3x plus 6 equals 4 minus 9. Is that going to be a negative what? What number do I have over here? Negative 5. That's right. Wait, do we have to check this one? No, we don't have to check it. I was about to say, this is the one we'll have to use to check. But no, we don't. Okay? I'll make a note. This is just a note up in my head. No check necessary. Now, if you're at
I know some teachers say check them always, okay? My
view an
lab-
example, if you're a view an example kind of person, it says check them always. I say you only have to check them.
if it's raised 10, if you're
Even
raising
power.
10 even power.
You do not.
Here we're going to raise it to the third power. 3 is odd, so why waste your time checking?
So I'm going to do this. I'm going to cube both sides. Be careful, the right-hand side is not going to be negative 15. We'll get there in a moment. On the left,
What's that going to reduce to on the left?
3x plus 6.
3x plus 6. Good.
and I said it's not going to be negative 15. What's it going to be? Negative 5 times negative 5 times negative 5.
Is it going to be negative or positive? Negative. That's what's so nice about odd exponents. The signs don't change. A negative times a negative times a negative stays a negative. And then 5 times 5 times 5 gives us 125. I bet some of y'all did this. 5 cubed on your calculator, or you can go 5 times 5 times 5. Either way, you're getting a negative 125. Notice I don't bother entering the negative because I know a negative to an odd power is going to stay negative. Okay,
Yeah.
Go ahead.
Now, what sort of equation do we have? Do we have a quadratic equation? Are we going to have to factor? Say no. No? How do I know it's not a quadratic equation?
So there's not 3 terms
There's-
on one side?
Well, there's not an x squared.
If there's an x square in it, that's when you're going to have to factor or use the quadratic formula. But here, this is just, what's that word? What type of equation is it? Starts with
Linear,
an L, linear.
yes.
So what would y'all do to get the x by itself?
Subtract 6 on both.
Subtract the 6, very good. So we have 3x on the left. Negative 125 minus 6. Subtracting 6, is that going to be a negative 131?
And then
Divide by 3.
divide by 3. 3 doesn't divide evenly in there, so we'll just leave it as negative 131 over 3.
And do we have to check?
No.
So negative 131 over 3 is the answer. You're going to type it in?
Any questions there before we go on? Or before I switch away from that page? Okay. Negative 131 over 3.
Notice how they even have, there's the empty set or no solution but not.
Couldn't really happen. Okay. Number 12.
Number 12. Cube root.
Oh, this has two radicals in it.
This one's going to look bad. Do we have to, will we have to check this one? Okay.
Yes. No.
No? And you're saying no because it's a cube root. You only have to check them for square roots or fourth roots. This one's a cube root. Then a minus. Let me finish writing this one. The cube root of 8x equals 0. Let me see if I've written this down. The cube root of 5x squared plus 7x minus 7 minus the cube root of 8x equals 0. I know that we're not doing literally every one of the problems, the ones that are real similar to ones we've done, just to get it all done today. If you look through the fall 2024 YouTube playlist, we had spent 2 days on this assignment then, and we did literally every one of the problems. There's 14 new stuff here. Problem 15 is just a review of the quadratic formula. But let's see. So if you want to see ones, like I think we skipped 10. Yeah, but we have them literally all done on the YouTube playlist from last semester. Okay? Maybe I should tell Tim, put those on the YouTube playlist for this semester, in case you want to see some of the problems we didn't do. We're doing almost all of them, but there's a few we're skipping just for time's sake. Isolate a radical. Oops. Y'all can't see what I'm writing. Isolate a radical. What am I going to do first on this? We have 2 radicals. We need one of them isolated. I think we're going to wind up isolating both of them. What would y'all do to isolate? Would y'all move this big radical over to the right, or would it be smarter to move this small one over to the right? Yeah. Why are you saying that? Well, I think we're going to have fewer negatives. Right? If we move this, the cube root of 8x to the left, to the right, I mean, it would be a positive. So we have cube root 5x squared plus 7x minus 4 equals the cube root of 8x. What exponent will I use on both sides to cancel out the cube roots? Cube root. So it's got to be a cube. And then the cube and the cube root cancels here. Look how nicely this works out. You can impress someone.
So what looks like a terrible problem to start off with, it's pretty fast to get rid of the radical.
Writing it without the radicals. And do we have a quadratic equation here on number 12? We don't have a quadratic equation on number 11. We didn't have. That was just linear. What about this one? Are we going to have to factor it? Oh, no. After this one, there's only one more. So, yes. I know this is long. So we're going to write this in standard form. You need a 0 on one side. What do y'all think I'm going to do to get this in standard form so we can factor it? Subtract the 8x. So we have 5x squared. 7x minus 8x. Is that just going to be a minus 1x or minus x? Equals 0. Draw my 2 sets of parentheses. If I didn't want to factor this, I could also do what to get the solutions? Quadratic formula. Now, there's not a lot of possibilities for 5. It's just going to be a 1 times 5, right? But for 4, it could be 1 times 4 or 2 times 2. That's going to take a little thought. But I'm going to go ahead and put the 1x times 5x, since there's no other possibility. 2 and 2 or 1 and 4. If I do a 2 here,
Here's another one of my tricks. If that number right here, when you're factoring, oh, it's just 1 less than these numbers here. I mean, if you subtract 5 minus 4, don't you get 1? I tried, well, obviously use the 1 and the 5, but I use the 1 and the 4 also. If you try the 2 and the 2, you're going to give up pretty quickly. There's no way to get that minus 1x.
There. A 10x and a 2x. It's going to have to be the 1 and 4.
Lay it out in your head. Should we put the 4 here?
So
if we put the 4 here, are we going to be able to get down to that minus 1x? 4 times 5 is 20. You're moving away from that 1. So put the 1 and the 5. I mean the 1 and the 4.
Oh, and I should have asked, but I don't think I did. What sort of signs are we going to have in here? Plus, plus, minus, minus, or 1 of each? 1 of each. That last sign is negative, so 1 of each. Now let's look at the outer and inner. We have a 4x and a 5x.
They have to subtract to give you a 1x. Can you take 5 minus 4 to get a 1? Yeah, that's it. But how do you arrange the signs?
-5. Oh, -1.
Okay, so a negative 1, that's going to give you the negative 5 that you needed.
And plus 4, does that do it? Have I factored this correctly? I think I have. And almost done. Now set each factor to 0. X minus 1 equals 0. 5x plus 4 equals 0. Well, on this first one, to isolate the x, just move that 1 over. I can go ahead and circle that because I don't have to, because I don't have to check it, because it's a cube root. And what about over here? What would I do to get the x by itself?
Subtract 4 to give you 5x equals a negative 4. And then divide by 5. Good.
So we have a negative 1, a negative 4 over 5 and a positive 1. We want to type those in. I'm going to move this up a little more. We're going to
I'm going to let them finish writing. I see some people still writing.
As far as the directions for these in comparison to the other ones that we were doing, what would we look at to know what they're trying to look for? Like the other ones we were
solve the equation. It's just now at the beginning they're saying what numbers can't be, do not solve. But for all the rest of them, the instructions say solve the equation.
And how do you know you don't have to show this?
Oh, wait.
How do you know you don't have to? If it's a square root, cube root, any sort of radical symbol, you're going to be going through these steps. But like on this one, we don't have to do the checking because we don't have even roots. We have a cube root.
Maybe I should have said, check your solution if you raise both sides to an even power. But when I look at the problem, I see it's a square root, an even root. So we got to check.
I guess my question was, how do we know which ones, like the other ones we were using the least common denominator?
Oh, because
So-
it's the fraction.
The fraction.
Okay.
There you go.
There's
Okay.
two types of problems in this assignment. Ones with fractions, that's the rational equation. In algebra, they always make it fancy. They say rational instead of fractions. Okay, so we have the rational equations, that was the first ones, and these are the radical. Okay?
Oh, wait, I didn't type in the answer. What was it?
1 comma negative 4/5. Let's see.
And
Number 14 is the last one. Let them see it. Number 14 is just like the one we finished doing, only
much
easier.
easier.
And at first glance, does it look like?
Does it look like a radical equation? I claim it's a radical equation.
Well,
Does it look like one? Do y'all see a radical? Do you see a square root or a cube root or anything?
is there something strange here on this one?
Yeah, that 1/3.
The 1/3. The
Okay.
1/3 exponents, okay? This will become important when we get to logarithms.
Something we'll need over and over. Let me write this out.
Yeah, you better write it out.
I'm going to define formally what we mean by
A
fractional.
fractional exponent.
A 1/2 exponent is the same thing as a square root. So if we see a problem with a 1/2 exponent, you write it as a square root. A 1/3 exponent is a cube root. A 1/4 exponent is the same thing. Do y'all want to guess?
What sort of radical would be the same as a 1/4 exponent? What number are we going to put here?
4.
Right here.
4,
Yeah.
okay.
In general, here's a formal rule. A to a 1/n power, if you see an exponent in the form 1/, that's the same thing as the nth root. And if you're sitting there thinking, well, wait a minute, what if it's something other than 1?
We'll see how that works out later. For the time being, all you got to worry about is the fractional exponents of 1/an integer.
Everyone's number 14 is going to have one of those fractional exponents. Let me see, what did that number 14 look like? Let me write it down. 2x plus 5
to the
to
1/3
the 1/3
minus 7x minus 1 to the 1/3 is equal to 0.
equals 0. At first glance, when you see this and you don't know how to do it, you think, oh, wow, that's got to be hard. Okay?
Write it using a radical. Make it look like the problems we've been doing. That 1/3 exponent is the same thing as what sort of a radical? A cube root, okay?
So this problem is very much like number 12. Number 12, we had 2 cube roots. Same thing. Here we have cube root of 2x plus 5 minus the cube root. Oops.
Don't forget your index.
Yeah. So now that we see these are cube roots, are we going to have to check our answer?
No, we're not going to have to check our answer. And there's really only one sensible next step. Before we can cube both sides, we have to isolate a radical. Which one should we move?
Should we move the first one or the second one?
The second, because when you move the second, what happens to that minus?
Positive.
Becomes a positive.
So writing it all with just a single color, we have the cube root of 2x plus 5 equals, moving this over, the cube root of 7x minus 1.
Do you have your microphone on?
Well, yeah, let me see.
Move it down.
There. Now, our climate's very much like number 12, isn't it?
Except,
Well, we've already gotten as far as
well, it's much
isolate. Oh, it's
easier.
already like number 12. We've isolated it. But why is he saying it's easier? When we cube both sides, what's going to happen? Are we going to have any exponents in this? What am I about to write?
The cube and the cube roots are canceling. Are y'all getting sick of this stuff? This is it. Just bear with me for a few more minutes. And we just have 2x plus 5 equals 7x minus 1. Do we have to get it set equal to 0 and factor it? Is it quadratic? Say no. How do we know it's not quadratic? There's no x squared. Okay, this is a linear equation, so just isolate the variable. I'd move it around to get as few negatives as possible. And it's just, I think, here's what I would do. I'm going to move the 2x to the right and this 1 to the left. I think that'll give us no negatives at all. We'd have 7x minus 2x. So on the right, we would have 5x. And what about on the left? A 5, it's going to be a plus 1. Are you following what I'm doing here? If you want to move the x's to the left, that's fine. You're just going to get more negatives. You'll get negative 5x equals negative 6. But once you divide, you'll still get. Oh. Are y'all caught up with me, or are you just sick of it and want me to shut up? Now keep going. What do I do now to get the x by itself? Divide by 5. Am I finished, or do I need to check? I'm finished. We've raised both sides to an odd power, so there's no need to check. Raising both sides to an odd power guarantees equivalence, but raising both sides to an even power does not guarantee equivalence. So, oh gosh, punch it in so they'll know that I got it right. 6 over 5. And number 15 is, it starts something that we do the rest of the semester if we don't have enough problems. It's just a review one. Use the quadratic formula. Okay, so we'll start seeing some problems like that. But, you know. Last semester, any questions before I stop recording?